You might be a Snowflake administrator or data platform owner and wants to know how many different kind of objects like file formats, stages, views, functions exist in your database or schema, and how big or complex your tables are and how much data do they hold. You can go and run show commands for different objects, but that's not a very convenient and scalable way if you have a lot of schema under your database. What if you get a dashboard like this alongside filters and all your information can be fetched with one click? All these metadata about different account level, database level, and schema level objects are captured and made available by Snowflake via information schema. And that's what we are going to talk about in this episode. Information schema is a well-known concept. So, what's that you need to learn about it when it comes to Snowflake Cloud Data Warehouse and the opportunity it throws to Snowflake Ops and development teams? We would try to find the answer of following questions. Does information schema hold account level objects? Can I get load history data from information schema views? Information schema views are secure views or standard views. Does querying information schema cost a lot? Can I build a Snowsight dashboard using information schema? How can I list table function exist inside information schema? So, if you want to build a solid understanding about information schema and what power does it bring to the data developers and data ops engineers, then stay with me until the end of this video. Welcome back to my channel Data Engineering Simplified and to this real jumpstart course for Snowflake Data Professional. The last 21 episode in this series already covered history to architecture, data loading, micro-partition, time travel, cloning, stream, task, role and role hierarchy, stored procedures, functions, views, and many more important concepts. This episode, Chapter 22, will primarily deep dive into information schema. We will explore how does it look like, what information can be extracted from this metadata dictionary schema, and how the result changes as per the different role assigned to the data developers. We will get into information schema table functions and data retention value as applicable to the different functions. We will practice everything using the Snowflake free trial edition and have hands-on exercise to cover all the concepts listed in this slide. I will also cover some dashboard from Snowsight. Before we move next, let me ask this. Do you want to have mastery in the Snowflake Cloud Data Warehouse? I believe you should be because there are many amazing opportunities available if you are familiar with the Snowflake Cloud Data Warehouse system. I have been adding a lot of great content to help the Snowflake community. The response I received from my audience much exceeded my expectation. People are getting certified on their first attempt and scoring nearly 100%. My free content is used by data engineers, data lead, architect, and even data managers. You don't need to buy any expensive courses. Check my playlist. It includes almost everything to make you a successful Snowflake data professional. So, if you find something useful in this content, please press the like button. Leave your opinion in the comment section or send me a direct message on Instagram. To get information schema in Snowflake. The information schema is implemented as a schema named information schema that Snowflake automatically creates in every database in an account. The Snowflake information schema is based on SQL 92 ANSI standard. It consists a set of system-defined views and table function that provide extensive metadata information about the object created in your database. The information schema metadata is captured in form of views. There are 17 views which captures database level object and there are 8 views which capture account level object. Not all views are ANSI 92 standard and they are specific to Snowflake. For example, file formats and external tables. Alongside views, information schema also holds table functions. There are total 13 table functions available under information schema and they hold data for a short duration like 60 minutes to 6 months. As and when Snowflake adds new object, they also add table function if its object operational activities to be monitored. So the list shown here is based on Snowflake version 6.22.0. Refer the Snowflake release page and new feature documentation if you want to be aware of any change or addition to the table function under the information schema. So let's jump and see all this in action. Let's see how the information schema looks like. And here I am in my Snowflake Legacy Web UI. From this database object explorer, all the databases are visible on the left pane, and you notice that whether the database is a shared database or the database is created within the account, each of them having a schema called information schema. This information schema has only views, it does not have any other object. When you click on the views, it will list down all the information schema views which you can access and fetch the metadata about different objects. If I go to this shared database, it also brings the information schema. Alternatively, you can also go to the Snowsight, and there also you can see exactly the same view, like I have information schema and all the views are listed within the view tab. One important thing to notice here, all the views which are available under information schema is available through this option. However, information schema also has table function, and those table functions are not listed anywhere under the information schema. However, if you have a table function, you can always go and list the table function through this option. And I do not know why those table functions are not listed through the information schema. And I have a question for you, and leave your answer in the comment box. If you have to find how many table functions are available within the information schema, how can you fetch that in Snowflake? I would love to see your answer. So let's explore each of these information schema views in detail and understand what does it capture and for what purpose you can access or refer this information schema. We will start with a view called databases, and let's see what does it bring. Before that, you may have one question in your mind. Querying information schema views needs virtual warehouse or not? So right now my compute warehouse is suspended, and if I run any query which needs virtual warehouse, this warehouse will be resumed automatically. And let's try that out. As soon as I preview the data, my virtual warehouse is automatically resumed. It means querying information schema also cost you, depends on how much data you are fetching from the Snowflake. If you see, I have total 12 databases as a result when I preview the data. However, when I switch my role, I may have a different result. So when I access databases views using my role system admin, it got total 12 record. However, if I try to do through the public role, the result might be a little different. Let's try that out. So here I am using my role public. I am using ad hoc virtual warehouse. And when I go to this database, and this is my information schema, let's preview the data. And it has only got 5 rows. Even though it is the same database and same information schema, according to my role, the data will come. So if you are getting a different result by the different user in your project, they are accessing the information schema using the same role, else you will end with a different result set. Let's go back to our system admin role. Let's understand what is the result of this view. So I can see when I query this view, it brings all the database names, all the database owner's name, whether the database is transient or not. You can also create a transient database. What is the comment given while creating the database, and created time, last time, and retention time. And again, if you have not seen my time travel episode, please check the link given here. So this is how you can fetch all the databases available in your Snowflake account, when it is created and when it is modified, and what is the retention duration for your database. One important thing before we go to the next view, databases are account level object, and that's why the view databases brings account level result. Let's move to the next view, which brings all the schema under the different databases. Let's scroll down further, and here I can see something called schema TA view. Let's click on it, and I brought all the data, and let's expand this. Again, a very straightforward result. It brings all the databases where this schema belongs to. The name of the databases is referred as a catalog name, and this again aligned with the ANSI 92 standard. All the schemas which belong to this database, if you are querying this information schema from a particular database, you will always see only one single database. It will not have a multiple databases name here. And here you see who owns this schema. Information schema is not owned by any specific role within the Snowflake. It is primarily created by Snowflake automatically, and since it is a read-only schema, you cannot make any changes no matter what role you have it. Followed by whether your schema is in transient schema or a standard schema, whether your schema is managed access or not. Is managed access is a recent feature introduced in Snowflake. Okay, your retention time, whether it is 1 day or 10 days or 90 days. And there are a couple of additional fields called default character set, catalog set, default character set name, and SQL path. These 4 columns are not applicable in Snowflake. This is only applicable for other RDBMS databases. When your schema is created, when it is altered last, and what is the comment. Again, if you belong to a data ops team or a Snowflake administrator and trying to deploy your Snowflake object through the CI/CD, maybe these fields are important for you, and you can really create some standard dashboard by capturing this detail and report to your management or a platform owner. So let's quickly see whether schema view is a database level object or account level object. It is a database level object because all schema in Snowflake belongs to a database. Schema view is completely aligned with ANSI 92 standard. So now we have understood databases. So next question you may have it, how can I get all the tables, all the columns in each table, and how can I understand the constraint within the table? So let's go to table and column related views. All the views are listed in alphabetical order, and if I have to find a view called tables, I have to scroll down, and here I can see a view called tables, table constraint, referential constraint, and columns. So let's start with tables. Again, table is a schema level object and schema is a database level object, and databases are account level object. So this is a hierarchy maintained in Snowflake. So everything starts with my database, followed by the schema name, followed by the table name, who owns the table, whether the table is external table or it is a base table. Sometimes you can also see whether the table is a view type or not. Even information schema is also captured and it is tagged as a view. Here I can see whether my table is a transient table or a standard table, followed by how many row count I have in the table, what is the total space it has occupied in bytes, what is the retention duration. There are additional columns which are not applicable in Snowflake, and you will never ever find any entries under these columns. Followed by when this table is created, when this table is last modified, if auto clustering flag is true or not, followed by the comment. So now, if you have to really create a dashboard, how many external table do I have, how many base table do I have, out of them how many of them are transient table and how many of them are standard table, what is the row count, you can use this particular view from the information schema and build your dashboard. Let's go to the columns. Again, column belongs to a table, table belongs to a schema, and schema belongs to a database. This is called table catalog. Now here, what is the position of a column in your table? Okay, and do you have any default value, whether the column is nullable or not, data type, and few additional information. Some of the fields are again not applicable in Snowflake, and you will always find them empty. Now, when this column is created and when this column is altered, that detail is not available here. You alter the column through a table and you will find that date in the table view. So if you need to understand how many columns you have in your schema or a database, you can use this information schema view and build a report or a dashboard for your data ops team or your platform team. Now moving to the next view called table constraint. Let's see what data does it bring. So here it brings all the constraints associated with your table. You start with the database, followed by schema, and followed by the name of the constraint, and this constraint is applicable on this particular table, and the table name is there, what kind of constraints are being applied. Now one important thing is Snowflake does not enforce any kind of constraint except not null. They are only placeholder just to make sure that if you are migrating your platform from a legacy system to Snowflake, you can still use those constraints. And while doing your structural comparison, you can make sure that those constraints are in place. However, again, Snowflake does not enforce this constraint except not null. You can also see when these constraints are created and when these constraints are last altered. Now let's understand the referential constraint. So we have seen the table level constraint. What if I have a constraint which is established between two tables? In that case, this particular view comes handy. So this view captures the foreign key constraint between two tables. So we have pretty much understood the tables, the columns, the referential constraint, and the table constraint. Good. There is another view called external table. Even though table captures table type, whether it is a base table, view, or external table, this view captures some additional detail, and let's see them. Here it starts with the database name, followed by schema name, followed by the name of the external table and who owns this external table, when it is created and when it is altered last time, followed by the comment, location, file format name, and file format type. So if you need to fetch additional detail about location, file format name, and file format type, this view helps you. However, you can fetch the rest of the detail from the tables view. In a large project, there will be a lot of external table. Those external table will be mapped to a different cloud storage location, and you as an administrator or a data ops team would like to know where all these external tables are pointing to, and this view really helps in that case. A quick summary: all those objects what we have covered through these views, database and schema level object. Next, we will cover functions, stored procedures, and views. So all your UDFs are recorded in a view called function. All your procedures are recorded in the view called procedures, and all your views are recorded in a view called views. So let's explore them. We have seen this result in earlier chapter. So it simply captures all the functions. Who is the owner of the function? What is the argument passed in this function? What is the data type of this argument? And character min max value, numeric precisions, followed by whether it is SQL type, JavaScript type, what is the body, followed by volatile and other attributes of your view definition, followed by when it is created and when it is altered. Your UDF can also be an external function with API integration. Sometimes you may ask, how can I use this view? If you are following a specific standard in your project, you can really come to this view and apply some filter criteria and understand whether the projects are really following the guideline as per the standard given by your data team or not, and you can validate those attributes through this view. Let's see the result from procedures view. This result also looks similar. We have already covered in chapter 21. So here it will list all the procedures followed by who owns this procedure, what kind of argument and the data type it has, the character length and the numeric precisions, whether it is JavaScript or SQL procedure, followed by procedure body, when it is created, and the comment. So this is again a pretty simple and straightforward view. Coming down to views. It captures all the views, including the views within the information schema, and it checks what is the body, what is the SQL statement as a part of a view. Some of the options are not applicable within the snowflakes. We have seen in the tables view, we also capture the view. However, that information does not capture whether your view is secure view or non-secure view, and that information you can fetch it from this view, when it is created, when it is altered, and the comment available in the view. So these three views are classified as a database level object because it captures all the functions, procedures, and views which are available under the schema and under the database and not at the account. Now we will cover file format, sequences, and stages. File formats are used for external table. Stages are also used for data loading, and sequences are used for creating a surrogate key or any kind of auto-generated number in your tables. So here I can see a view called file formats, and it captures the name of the file format. File formats are schema level object. So I can see the database name, schema name, followed by the file format name. And file formats are owned by a role. What is the format type, whether it is CSV, Avro, JSON, and Parquet. Okay, and additional information with respect to each of the file format. And again, if you are a database administrator, you can really summarize all those information and create a nice dashboard and understand the statistics about the usage of different file format in your project. Next, we will see sequences. We have created sequences in a previous chapter, and if you do not know how does it work, refer the link here. So sequences are again schema level object, and they are owned by the role. Data type is always number. What is the start value, what is the next value, what is incremental definition, and the cyclic option, whether it will restart if it really reaches to the end, and when it is created and when it is altered, and comment. Okay. Moving to the stages view. We all have seen how to use stages, what is the different type of stages, and how to use stages for a copy activity. Stages are schema level object. You will find your stage name, stage type, stage owner, comment, created, and last alter. Again, you can create a nice report, how many external stages you have, how many internal stages you have it, when it is created and when it is altered last time. Now we will cover something interesting called pipes and the load history. So all the pipe created under a schema is captured in a view called pipes. And here you can see I have a total 3 pipes which are currently running. You can see the name of the pipe, who owns the pipe, the definition, whether auto ingest is true or not. This is only applicable for AWS instances. If you have not seen my episode on data streaming, please refer the link here. When the pipe is created and what is the pattern available here. So this is a view which captures all about the pipe. So pipe is a way to load the data. There are another way to load the data is primarily using a copy command. For that, there is a view called load history. Let's see that. Now load history will capture all the data loading which is done using a copy command, either via SnowSQL or via legacy web UI or via any other mechanism where copy command is used specifically. If you go to the Snowsight, you can see the load history of a table using Snowsight. When you go and click on this table tab and click on this copy history, it will show you the data which is being copied in the last couple of days, and you can see how the data is being loaded. This is also covered in detail in chapter 19. So the copy history and the pipe are two views through which you can understand how many pipes you have it and how many copy commands are being executed to load the data and what is their current status. However, the information schema does not capture the data loading metrics which is done through the pipe. For that, you have to use Snowsight interface. We are going to talk about 3 interesting views called applicable roles, object privileges, and table privileges. Very important views, and this will help you to decode a lot of things if you struggle to understand role and role hierarchy within Snowflake. So first I am going to preview the applicable roles view. This view lists all the roles available in your Snowflake instance. So all the role names are listed in this column and who owns these roles. If you have created any custom role, you would come to know who has created this custom role. And if there is no role owner, it means these are the default roles available in Snowflake and created by Snowflake. Now, these roles are granted to different roles or a user, and here is a list of all those grantees. So you can see the support lead role created by security admin is granted to project lead, and the project lead role is also created by security admin and granted to security admin. And now to understand this picture more clear, I am switching to my Snowsight page, and here I can see support lead is granted to project lead and project lead is granted to security admin. security admin is granted to account admin. If you are having an enterprise Snowflake account and if you are a part of any data team, you may not have access to this user and roles menu. This user and roles menu can be accessed only by account admin. However, this view can be accessed by everybody and the roles will be listed in this view. So let me switch my role to the public and demonstrate it. So I can see my role is public. And here I can see exactly 8 roles available in my Snowflake account. So an exercise for you, if you go to your Snowflake enterprise account, how many roles do you see in your applicable role view? Please drop a note. Next, we are talking about object privileges. And let me preview the data. This is another interesting view which captures all the different object type created in your Snowflake account. It starts with object name, followed by object type, followed by the privileges given to this object to a particular role. And it captures all the object and all the privileges given to different role. However, one difference between applicable role view versus object privilege role. If I switch my role from system admin to public, let's see how the result looks like. The result does not bring all the grantees. It only brings those records where my grantee is public, right? So in your Snowflake Enterprise Edition, you might be having a limited access. And how do you know whether you have limited access or not? You can go to this particular view and display all the data, and you can understand what kind of privileges are given on a different object to your profile. If you fail to create a table under a schema, or if you fail to create a pipe under a schema, you need to go and check whether you have create object privileges given to that schema or not. And that's why you can understand what you can perform and what you cannot perform. So this is one of the most important view within Snowflake Information Schema. Now let's move to table privileges view. So table privileges views are kind of subset of object privileges view. It only bring the table name under the different schemas. So you can always see my catalog, which is nothing but a database, followed by schema, followed by table name, and what kind of privileges are given to the grantee. If I go and see the same view under a public, I would be able to find public as a grantee for all the record. And here I can see whether I am owner, whether I have a select privileges or different kind of privileges within the table. Since it is a table, you will either have a select privilege, insert, update, delete, all kind of privileges will be listed according to your role. Let's see the view. How does it look like under the public role? As I told, grantee value will always be public. Let's assume you have a single instance for your dev, QA and prod. In that case, you will see different grantees because you have been given different role as per your information schema. These three views are very important, and if you have not understood role hierarchy as well as privileges, I would request you to watch my role and role hierarchy chapter, and this will give you a complete understanding how Snowflake function when it comes to the role hierarchy and the privileges. So now if you see this metric, enable roles and object privileges are the two views which display data at account level and not limited to database and schema. However, tables are always under a database and a schema, and that's why it is labeled as a database level view. Now let's talk about usage privileges. As name suggests, this view only focus on the usage privileges. I do not know why Snowflake has created this views called table privileges or usage privileges. Everything can also be seen from this object privileges. Table privileges and usage privileges are subset of the object privileges. So let's see how does it look like. Here I can see the privilege type is usage, and right now you can see which all objects got the usage privileges under which database and which schema. And if I go to the public view, let's see how this looks like. So I don't see any data over here because this view operates based on your role. Good. Now I would like to show one important thing. When I preview the data, it took quite a lot of time for fetching the data. Let me fetch the data using a query. It took roughly 15.47 seconds, where compilation time was 163 milliseconds and execution time was 15.31 seconds, which is a big number. Let's see what's happening by going to the query profile tab. So it shows that it has performed two steps. One is a metadata operation, and when I click on the step 2, it goes to this usage privileges grant user, and it actually does something on the internal objects. We do not know what exactly it does, but this is how. So running a query on the information schema may cost you a lot. When I go to the query history, it shows that it has used the extra small virtual warehouse and it has scanned roughly 1.9 megabyte of data. Querying information schema view will cost you, and it depends from view to view. There are a couple of other views like packages and replication database. Let's quickly see what do they hold. If you have seen my chapter 21 where we have created stored procedure, user defined function and views, we have really uploaded a Java based package. Now Snowflake also supports Python based packages. So all the packages which are available are listed in this particular view. So you can see that different version of Python packages are available, and if you are having any specific Python or Java packages, this view will display all of them. Another thing is, if you have enabled replication from one Snowflake account to another Snowflake account, cross cloud or across region, then this view will also list those information. Since I do not have any replication here, the data is empty. However, you can see whether you are operating on a primary account or a secondary account, and what is the region you are actually replicating to, and what is your region group, Snowflake region, what is the account name, and which database actually you are replicating, right? Now, one interesting thing again I will show you here. If I do a select star from this view, it takes quite a lot of time, and let's see what does it do. So it brings 0 rows, and it took roughly 21 seconds. Out of 21 seconds, 19.6 seconds is for execution and 1.33 seconds for the compilation. So what's happening under the hood? Let's go and check the query profile. Here again there are two steps. The step 1 says metadata operation. Step 2 shows how exactly this query is being executed under the hood. So there is an internal object which is not visible to us, and it queries the internal object, and which took around 92.8% of the total execution time, and then it performs some kind of aggregation before it generates the result. Querying information schema views can be expensive sometimes, whether it brings result or it doesn't bring the result. So if you are querying this information schema, make sure it will cost you more or less. So since we have covered pretty much almost all the views, now I am going to show you a dashboard which helps you to consolidate all your object under a single pane. And again, if you have not watched my Snowsight chapter 5, I would request you to go and watch that chapter. So here I am in my Snowsight dashboard, and first I will show you all objects available under my account. This dashboard I am seeing as a role account admin. You can also switch the role from account admin to system admin. Here I can see I have a total 7 roles because public role is excluded from this list. And here I have total 134 privileges. I have total 13 databases, 7 schemas, 45 tables, 1 external table, 501 columns, 6 sequences, 5 file formats, 9 stages, 25 views, 2 UDF and 2 stored procedure. Now let's go and see this dashboard called table consumption dashboard. Here I can see I have a total 19 tables under this schema CH22. Total row count is 1.6 million. The total space taken by the table is roughly 50 MB. These are the different tables having a row count and the space taken by each of them and what is the time travel configuration. These all dashboards are created using information schema view. I can really go and I can change my role from account admin to the public, and let's see what happens. Now I can see a different result set. Here I have a total 21 table, space is 51 MB and so on. So this is how I can really create a dashboard for my data admin team or for your data project, and you can monitor how things are happening. This dashboard is created using information schema. I can also apply the filter and choose a different schema. and click on apply, and I may get a result or I may not get a result. We have already used many table functions in our previous chapter. I'm not going to go deeper for the table function. However, this is a list of table function which you can use and fetch lot of different detail. Each of the table function has a retention period, and this is how it looks like. Let's see them in action in our web UI. So I am using account admin role with compute warehouse. T-tips is my database and schema in information schema, so I can access the table function without fully qualified path. Here, the login history by user is one of the table function, and I can simply say select star from table followed by the table function name. It can take an input parameter as per its definition, and I can also use order by clause. So let's see. And here you can see my table function has got all the login detail. So you can go and you can also find at what time you have logged in with a different client. You can also pass some input parameter while using the table function, and let's see how does it work. Now I can see I got the result. However, this result is limited to only 5 records and for a specific user. So this is how we can use different table functions and fetch different kind of result for a different purpose. I need to make a separate playlist to explain each of these table function and what is their purpose and how we can use it for different reporting or dashboarding. We have covered information schema, the different views available under it, the different table function, and how we can create a dashboard using information schema queries. Now, you may have a question, what is this account usage schema and how this schema is different from information schema? Unlike information schema, which is created per database, account usage schema is a single instance in your Snowflake account, and it is created automatically by Snowflake under Snowflake database. This database and schema is accessible only to account admin role and captures much more information than information schema. Many views are common between information schema and account usage schema like databases, table constraint, stages, etc. However, there are many more views which are not visible or accessible, or you can say available in your information schema. Talking about each of view from account usage schema may need another playlist, and I will publish it soon. Account usage schema is very important for platform owner or data managers or data ops or a DevOps team. We will not go in deep, but let's see how does it look like. To see the account usage schema, I must use the role account admin. So here I have already selected my role account admin. Click on the data tab. Here you will find a database called Snowflake, and under the Snowflake you have a schema called account usage schema, and account usage schema holds a lot of views like access history to warehouse metering. What we have not seen in our information schema is like warehouse metering, task history, tag references, sessions, row access policy, and many more other important things. Snowflake account usage schema hold data for 365 days. And one important thing to notice, the latency for account usage schema is pretty high. It may go up to 45 minutes sometime, as well as account usage views does not reflect the changes immediately, and it takes a while to have those records available through this account usage schema. So our first preference is show command followed by information schema, and then we'll come to the account usage schema. Now you know how important the information schema is and what role does it play. It helps you to build interesting dashboards and allow you to fetch important metrics for all the objects under your account as well as your databases. It also supports many useful table functions which are very important and helps to monitor your pipe, task and task execution status. Now you may have a question in your mind. Snowflake supports pay-as-you-go pricing model, and if I allow my team to do anything, they may spend hundreds of dollars overnight. So, do I have any mechanism to monitor and control their activities and eventually control the spend? And if so, how can I do it? And how can I see the usage monitoring as well as my billing detail in Snowflake? So, all these questions will be answered in my next chapter, Snowflake monitoring and billing concept. So don't forget to watch that super important chapter. And I hope you have been enjoying this Snowflake learning series. And if there is anything you liked in this video, press the like button and leave a comment. All the best and happy learning.